Definitions. First thing, we are talking about how central angles are related to arcs today. So the first thing you need to know is what these words are, and then I'll talk about the relationship of a central angle and its arc. So an angle whose vertex is at the center of a circle is called a central angle. So angle ACB is a central angle because C is the center of our circle. What?
Yesterday you said this was a circle.
Yeah, remember when I gave you guys the wrong notes?
Is this lesson harder or easier than this one?
I think it's hard because you don't know what the words are yet. I don't think either of these lessons are necessarily difficult, but when you don't know what words mean, it makes things difficult. You know what I'm saying?
Yeah.
Like, these are kind of second nature to me. I know what these words are, but you guys don't.
Yeah.
An arc with a measure less than 180 degrees is called a minor arc. So we have a minor arc here with AB. So arc AB is a minor arc. And you put a little arc above it. So minor arcs are named with two letters. And see, like, little things like this, like knowing that minor arcs are named with two letters, you don't know that, so that takes a while to get used to. Okay, true. I'm sorry. So an arc with a measure greater than 180 degrees is called a major arc. So we have a major arc here. And you'll notice that a major arc is labeled with three letters. Maybe you noticed that. I don't know. So A, D, B is a major arc. So major arcs are named with three letters. Arcs. I forgot. I was being a pirate for a second there. An arc with a measure equal to 180 degrees is half the circle, so we call that a semicircle. And this can be named with one or two or three letters. It really doesn't matter when it is a semicircle. I think you mostly see it with three letters, but it is it could go either way. So like what this is basically saying is if you have a diameter drawn through, this here is your semicircle. It's half the circle.
Oh, no.
You see what I'm saying?
Yeah, but
So it has to be through, if you have a diameter and the arc connects the endpoints of the diameter, then it is a semicircle.
I have a question about, like, the major and minor.
What?
Like, whenever you're writing them, is it, like, any certain order?
For the minor, no, because it's two letters. But you just need to go the shortest distance with the minor arc, because like you don't want to go AB, because that's the longer distance. Do you see what I'm saying? So AB, you just need to make sure you're choosing the shortest distance. Does that make sense? For the major arc, just make sure the letter that's between the two other ones is between them when you write it. So like, do you see how this is ADB makes up this whole arc? So that's why it's the center. It could have been BDA as well, but D has to be in the center because when you make this arc, it's in the middle of those two endpoints. Does that make sense?
Yeah.
So that's also important that you're making sure that that middle letter is the middle of the point on your arc. So that's a really good question that you just asked them. Two arcs of the same circle who intersect at exactly one point are called adjacent arcs because adjacent means next to. So like if I were to draw a picture and if they share an endpoint, so like this one shares this endpoint and this one also shares it, these two are adjacent to each other because they are sharing this endpoint here. They are right next to each other.
Does this slideshow have transitions?
Oh, I don't know. This is going to be dangerous, isn't it?
She said that yesterday that she had the slideshow and she didn't put them in. They were already there.
I figured that's what it was. When I was talking to Mr. Steimer, I was like, I'm pretty sure they were probably already there from the previous years, but I was like, the bird was still the best, guys.
Yeah.
Or the ball that rolled up that got thrown away, you guys do with your stuff. All right. Questions on that before we do some other things here? Oh, thank goodness. So, when you find the measure of an arc, please listen real quick, because we need to talk about a few things here. We're going to find the measure of each of the arcs on circle P where RT is a diameter. Then classify each as a major, minor, or a semicircle. First of all, the central angle is equal to the arc length, or arc measure, sorry. So we're talking about an angle measure, so we need to use the word measure. So all of these should have an M in front of them because we're talking about the measure of the arc. So if you want to go through and correct that and put an M in front of all of those, so that we know we're talking about a measure, which means our answer is going to be in degrees. That little circle thing. So a central angle, remember, starts at the center. So this is RPS. Do you see that here? 110 is a central angle because it has the center as its vertex of the angle. So when we're talking about the measure of arc, RS, so this is the measure of arc, RS. So remember, if it's two letters, you have to go the shortest distance. So the shortest distance would be going from here to here. And we look at the central angle. So our central angle is 110 degrees. So that means that this is 110 degrees. Is that a major or a minor arc? It's less than 180 degrees. So it's a minor arc. There's two ways I know that this is a minor arc. One, it's only two letters, right? And two, it's less than 180 degrees. We do have to make sure it's not a semicircle, but we can tell it's not a semicircle because it's not equal to one. Okay, the measure of angle RTS. So T needs to be the center because it's a center. So RTS. T must be in the center. Remember, T has to be the center one when we're doing that. So we're doing the measure of angle RTS. So you know that a circle is how many degrees?
360.
360. And we know that the pi piece that's missing is how many?
110.
So can't we just subtract 110 from that?
Yeah.
And that gives you, just like Greg said.
The next one's 180.
Is this a major or a minor or a semi? It's a major. It's more than 180. There are three letters. Again, we have to be careful that it's not a semicircle, but we know it's not 180, so it is a major arc. Okay. Finally, RST. So S needs to be in the middle, so that's RST. Do we know that RT is a diameter? Does it tell us that?
Yes.
Yes, so what kind of circle is formed here then?
Semicircle.
If you know that it is a diameter, you have a semicircle formed, which means it's how many degrees?
180.
180. So you know this is 180, so this has to be 70 here. 70 plus 110 is 180, and this is a semicircle. So questions on finding minor, major, and semicircles. We'll be doing more with this, but any questions there?
Like I can see that semicircle, but like how did you do?
So since I knew it was a semicircle, I knew this had to be 180 degrees, so I did 180 minus 110, which is 70. Does that make sense?
Yeah.
Any other questions? These are good questions you're asking because you have to be able to answer these for when you have a quiz. Speaking of that, how many of you are going on that field trip on Friday?
Me.
Perfect. Okay. So on
Oh, yeah, I'm going.
On Thursday, you guys are going to get 2 lessons because most of you guys won't be here on Friday because of that field trip that we just found out about. So you'll be hanging out with me otherwise. English 2 is a field trip, which is almost the whole sophomore class.
And then there's French and flying.
Right. So therefore,
I'll be in Indiana.
We don't leave till 9.
What are you going to be doing in this?
we are just...
No, I forget Miss School.
All right, 2 arcs of the same circle who are intersect at exactly one point. We already talked about this. This is called an adjacent arc. I don't know. It's in here twice. So AB is adjacent to BC and AC. They are next to each other because they share a point. So all of those are adjacent to each other because they share that point. Arc addition postulate says the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the whole arc. So basically what this is saying is if this is 100 degrees and this is 110 degrees, if you want to find the measure of arc ABC, you would do 100 plus 110, which is 210 degrees. That is what that is saying. What? Oh, I'm going to be there in a second. Just 1 second. Remember, if it's 2 letters, you do the shortest distance. Because that means it's a minor arc, so it has to be small. Does that make sense? All right. Find the measure of each arc. So these all should have M's in front of them because we're talking about measures. We're not talking about lengths. So put an M in front of all of those. And Ian just asked a great question, even though he was ahead of me. That's okay. He asked, which way do I go with GE, left or right? Remember, when it's 2 letters, it should be a minor arc, which means you need to go the shortest way. So from G to E, you need to go right, so it's the shortest distance. Does that make sense? It's both of the boys behind you are both shaking. What? Yes. Well, mostly because of my husband. My husband's always been a big fan. So I like college basketball better than America. So 40 and 80 are those measures. So what's the whole entire measure of GE then?
120.
120. We just add. We use that angle addition postulate. 40 plus 80 is 120 degrees. And this is a minor arc. It doesn't ask us to name it, but it's a minor arc. It has 2 letters and it's less than 180 degrees. So if you are confused about major and minor arcs, you might want to make a note that this is a minor arc. Okay, the next one has 3 letters, which means that E must be in the center of the letter. So G, E, F. So we have G, E, F. So how am I going to find the measure of angle or arc GEF? Harmony, how can I find the measure of arc GEF? Add 40 plus 80 plus 110. All of those angle measures add to those arc measures. Again, it doesn't tell you to name it, but is this a major or a minor arc? It's a major arc. And then GF, since it's 2 letters, you need to make sure you're going the shortest distance possible. So GF is right there. That's the smaller distance there. How can I go about finding that, Daniel? What can I do?
360 minus 230.
So we already know that these 3 angles are 230 degrees, right? So Daniel said if I do 360 minus 230, because a circle has 360 degrees, I get 130 degrees. Is that a major or minor arc? All right. Questions there before we move on to the next one?
140 plus 83 is 223.
My brain really is not functioning today. I'm more tired today than I was yesterday. But at least I didn't have to hand out a note packet today, so there's that. A recent survey asked students whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures and classify each arc as a major, minor, or semicircle. So AC is 2 letters. So that means we need to go the shortest. So A to C. This is shorter than going the other way. Do you guys see how this way is shorter than going this way? So you got to be careful there. So Hayden, how can I find that? $108 and 29. So that's 7, 3. So is that 137 degrees? Did I do that right? Carmichael, is that a major or a minor arc?
Minor.
All right, it's not a semicircle because it's not 180 degrees. ACD has 3 letters, which means that C must be in the middle. So ACD means C has to be in the middle. Hunter, how would I find that one? What are them?
108.
Is that 220? Has anybody done it yet? Okay. Is that then a major, a minor, or a semicircle, Jill? It is a major. It's bigger than 180. A, D, C. D must be in the middle. Okay, Morgan. How would I find that one? So what are them? So that's 223 degrees. So is that a major, a minor, or a semicircle, Olivia? Okay, E, B, D. EBD. B must be in the center of that. So that is a long way around. Cameron, how would you find EBD? There's two ways that you could do it. One way might actually be quicker than the other.
Add them all up. That's 61.
Yeah, just you could add 79, 29, 108, and 83. Can anybody think of a quicker way, maybe? Kylie?
You just subtract 61 minus 360.
Yeah, so we could just do 360 minus 61 since, right, there's only one of them. That might be a little bit easier in this case. So that's 299 degrees. So Austin, what kind of arc is that? Major. So questions on that stuff. Now what Cameron said is completely fine. I was just showing you guys another way of doing it because sometimes it's nice to do things a little bit shorter than taking forever to add those four numbers together. Okay, we have a few more things we need to know.
Let's speed through it.
Actually, this shouldn't take that long. Well, 10 minutes later, yes, because you're going to be leaving. Congruent circles are two circles that are congruent if and only if they have the same radius. So if you know that the radii are the same, they are congruent. That's what this picture is saying. So do you see how they have the marked radius being the same? That means they are congruent circles. Two arcs are congruent if and only if they have the same measure and they are arcs of the same circle or of congruent circles. So what this is saying is that you need to know one of two things to know that we have congruent arcs here. If they're in the same circle, or you know that if they're outside of the circles, they have the same radii and the same central angle. That would make them congruent circles as well. Which means that these arcs are congruent. Okay, and then finally, in the same circle or in two circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So that's, again, that kind of goes down with this one, these two as well. Okay, guys, so let's determine the next one if we have congruent circles or not. So we have to determine if we have congruent circles or not. Yep. They wouldn't be congruent, though, because they don't have the same radius, though. They would be similar. So you're talking about, like, if the circles are congruent. Or if the arcs are congruent, which is a length. Which is a distance versus just, like, a measure. Does that make sense?
Yeah.
Did I miss something? Oh, I forgot to go back. This was it, right?
Yeah.
Okay. Determine whether the given arcs are congruent. Okay. So, and we're going to explain why. Is CD and EF congruent? So when you're saying that, we're asking if they're the same distance, not the same measure. Do you guys hear the difference there? A length versus a measure. So the lengths are the same because which one of those theorems? Is it congruent circles, congruent arcs, and congruent central angles? Okay, so congruent central angles reads, in the same circle, are we in the same circle? And two minor arcs, are those minor arcs? Yes. Are congruent if and only if their corresponding central angles are congruent. Are they both 80? So that is definitely congruent central angles. No, I think we're done with proofs for the year. That's what Miss Herbig said, so I'm going to trust her since she's... So, is the length of TU the same as the length of RS? Are those lengths the same? No, they are not. Do they have the same radius length? No, so are they even congruent circles? No. Radii are not... Ooh. Are not the same length. So again, we're talking about a length, not a measure. Are they the same measure, though? Aren't these both 90 degrees? Aren't these both 90 degrees?
Yes.
Yeah, but is that the same length necessarily? No, they're just similar. Okay, finally, UV and YZ. Are those congruent?
Yes.
Yes. Why are they congruent?
Because they have the same radii.
It's the same radii and the same central angle, right? So they're congruent circles. Because congruent radii, right? And is it congruent central angles? Yes, congruent central angles. All right, do we have one more slide? Is it just some more theorems and then we're done? No more examples? Okay, so last thing here, I'm going to wait because I think some of you are still writing.
She's fine.
I'm sorry, Miss Brady.
Oh, no, I did it again. Nope, okay. Similar circles theorem. So these are similar circles. All circles are similar because they all are 360 degrees. So no matter what, they are similar. Because they can be mapped onto each other using a similarity transformation. You can multiply by anything to make circles the same. Similar arcs theorem. Two arcs are similar if and only if they have the same measure, meaning the central angles are the same. So remember that second one that we said was not congruent because their lengths weren't the same? They were similar, though, because they had the same 90-degree measure. So all congruent arcs are similar. So if they're the same length, they are similar. But not all similar arcs are congruent, meaning they could be different lengths. All right.